Hi, this is Richard C. I'm a math tutor here at Wyzant answering a question submitted by a student about vectors. And we have a center of gravity here, or whatever you want. This is the center. There are three ropes pulling on this center. One rope from team A, one rope from team B, one rope from team C. And I've read about the bearings from the center out. So team A is 30 degrees northwest away from the center. So this would be northwest away from the center. And can pull at 30 newtons. Team B is 45 degrees. Ooh, glad I spotted that. So that's 45. 45 degrees true bearing and can pull at 35 newtons. And team C is located south 40 degrees west and can exert 35 newtons as well. So we just have to find, we have to write these vectors in a way that we can add them together. So that's what we'll do. I'm gonna use colors here so we can keep everything straight. So just looking at this right triangle for A, this is a 60-degree reference angle here. And ironically, that is a 30-degree angle, but that's intended to indicate that the hypotenuse is 30. So I'll put it over here. Okay, so that means this is going to be 15. And then this is going to be 15 root 3. So this is, you might be wondering, where is this coming from? Well, it's coming from the 30, 60, 90 triangle. And for those who don't remember their 30, 60, 90 triangle, I'll just put it over here. So there's 30, there's 60. And then this is A, 2A, A root 3. So you can see that 2A is 30, so 15 here. So A, vector A is going to be negative 15, comma, 15 root 3. Okay, we'll go over to B now. So let's look at this. We have a 45-degree reference angle and a hypotenuse of 35. So let me put that in blue. And once again, we're going to use special right triangle here, 45, 45, 90. 45, 45. This is for those who don't remember their special right triangles. A root 2. So in this case, 35 is equal to A root 2. So A would be 35 over root 2. Okay, so that's what, now we found B. Vector B is going to be, we'll rationalize this, so it's going to be 35 root 2 over 2, and then 35 root 2 over 2. And now we'll finish it off with C. And here we are, now we're interested in C. And the reference angle here is 50. So we're going to have to do this one on the calculator. So we'll do that up here, say, so the sine of 50 would be the y coordinate over the hypotenuse, opposite over hypotenuse, 35. So going on my calculator, I have to make sure I'm in degree mode. And I am, so 35 sine 50, getting that to be 26.8. And I could do likewise, cosine of 50 is equal to x over 35, adjacent over that. So let me do that, 35 times cosine 50, I get 22.5. And so C, vector C is going to be negative 22.5, comma, negative 26.8. There we go. Now we have to add these together to get our resultant vector. So let's add these up. Let's see, so this is a lot of calculator work. So negative 15 minus 22.5 is negative 37.5, and then we have to add 35 root 2. Well, let's just say 35 over root 2. It's easier for the calculator. Okay, so I get negative 12 for the x value. So the resultant, we'll just call it r. Negative 12.7, comma. Okay, 15 root 3. Let's see, 15 root 3. 15 root 3 plus 35 over root 2 so far I have 50.7. Now I have to subtract 26.8. So that leaves me with 24. Point, 23.9. Let's leave it there. Everything's to 1/10 here. So that's the resultant. I should use a special color for that. I'll use red here. So red for R for red, R for resultant. Let's just take a look at that. So negative 12.7, so it would be about here, according to this scale, and then up 23, so it's going to be up 23 would bring it quite a bit higher here. So this is going to be R. And you know, the diagram's not drawn to scale, so it's pretty hard to know how accurate this is. But you can see it's about right. I mean, you've got the stronger forces of the 35s, and that's a force of 30. But you have two forces pulling to the left, two forces pulling up, and one to the right. It seems reasonable that that might be the resultant. Okay, so that's basically all the work. How far will the center be in its initial location? I think they mean from its initial, I think. And in what direction? So let's take a closer look at the resultant. So it's 12.7 this way, and then 23.9. I'm just going to look at it like this. 23.9 this way, and we're going to find the reference angle here. So we just need the inverse tangent. Theta is going to be the inverse tangent of 23.9 over 12.7. So let me do that. So this gives me 62 degrees. So that's 62. So in terms of bearing, we also want the magnitude. You can just get that on your own. That's just Pythagorean theorem. Let me just finish the bearing. So it would be north. It's going to be 62, 28, 28 west. That would be the bearing, and the magnitude would be the whatever you get. I'll go ahead and do this for you. So 23.9 squared plus 12.7 squared. Take the square root of that. 27. So the magnitude here is 27. So that seems reasonable also. And that's the problem. So it's really just a matter of, reading the problem carefully and then drawing a nice diagram, rewriting each vector in terms of its x and y components, and then finding the resultant. So yeah, it took a while to do this one, but it's a long problem. I hope this helped you. Okay, bye-bye.